Imagine you're floating in the vast, endless darkness of space. There's nothing but the hum of your breathing, the distant twinkle of alien stars, and the boundless silence stretching in every direction. And then you see it. A world unlike any other. A planet where the sky burns with fire, where the oceans, if they exist, are made of lava, and where the very ground beneath your feet may be forged from solid diamond. Welcome to 55 Cancri E. This isn't science fiction. This is reality. Over 40 light-years away, orbiting a star eerily similar to our own sun, lies one of the strangest and most intriguing planets ever discovered. A place so extreme, so utterly alien, that it has defied scientific understanding for years. A world where daytime temperatures soar to levels hot enough to melt iron, where molten rock rains from the skies, and where the entire planet itself could be made, at least in part, of pure diamond. But is this really possible? Could such a world actually exist? And if it does, what would it mean for the future of space exploration? Could a planet like 55 Cancri one day become the ultimate prize, a cosmic treasure trove of unimaginable wealth? Before we dive into this glittering mystery, let's take a moment to consider just how rare and yet how common planets like this might be. For centuries, humanity looked up at the night sky and saw only stars. The idea that other planets might orbit those distant suns was little more than speculation. It wasn't until the 1990s that astronomers finally began detecting planets beyond our solar system. Exoplanets, as they're called today. And what they found changed everything. Instead of a universe filled with solar systems like our own, we discovered something far stranger. Giant planets orbiting their stars at impossibly close distances, rogue planets drifting through space alone, and super-Earths, rocky planets bigger than our own, but not quite as massive as gas giants. Some of these worlds are frozen wastelands, others are fiery infernos, and then there are planets like 55 Cancri E, a world so bizarre that even the experts are still struggling to understand it. Let's start with the basics. 55 Cancri E is part of a 5-planet system orbiting the star 55 Cancri A sun-like star located in the constellation of Cancer. This system is relatively close to us, just 41 light-years away. That may sound like an immense distance, but in the grand scale of the cosmos, it's practically next door. The planet itself is what's known as a super-Earth. It's about twice the size of our own planet and nearly 9 times as massive. That means gravity on this world would be crushing. If you weigh 150 pounds on Earth, you'd feel like you weighed over 1,000 pounds on 55 Cancri. But here's where things get really strange. Unlike Earth, which orbits the Sun at a comfortable 93 million miles, 55 Cancri E is dangerously close to its star. So close, in fact, that a single year on this planet, a full orbit, lasts just 18 hours. That means if you stood on its surface, you wouldn't just see the sun rise and set every 24 hours. You'd watch an entire year pass in less than a day. And with that extreme orbit comes extreme conditions. The planet is tidally locked, meaning one side always faces its star, while the other remains in perpetual darkness. On the day side, temperatures soar to an unimaginable 1,700 degrees Fahrenheit, hot enough to turn metal into liquid. Any atmosphere this planet once had has likely been stripped away by the constant bombardment of stellar radiation, leaving behind a barren, exposed surface. But what's truly fascinating is what scientists believe might lie beneath that surface. In 2012, a groundbreaking study proposed a radical new theory. 55 Cancri E might be made largely of carbon, and under the immense pressure of its interior, that carbon could exist as a diamond. Let that sink in for a moment. A planet made of diamond. On Earth, diamonds form deep underground, where heat and pressure slowly transform carbon into crystalline structures over billions of years. But on 55 Cancri E, the conditions for diamond formation could exist on an unfathomable scale. If the planet truly has a carbon-rich composition, then its entire mantle, perhaps even its core, could be composed of solid diamond, stretching for thousands of miles in every direction. Imagine an entire world where cliffs of glittering crystal rise against an infernal fiery sky, where the surface is a mosaic of polished gemstone, and the mountains themselves are sculpted from the hardest material known to man. If true, this would make 55 Cancri E not just the most valuable planet ever discovered, but the most valuable object in the known universe. The sheer wealth locked inside its planetary crust would be incomprehensible. Trillions upon trillions of dollars worth of diamond, compressed into a single celestial body. It's enough to rewrite the very definition of wealth itself. But is this idea really possible? Could a diamond planet actually exist? And if it does, what would it mean for us? Before we go further, a quick reminder: every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. Now, let's go deeper. What would it actually be like to stand on 55 Cancri E? And could we ever reach it? Close your eyes for a moment and imagine stepping onto the surface of 55 Cancri A. Your spaceship's landing gear trembles as it makes contact with the alien terrain, the extreme heat pressing against the hull like an invisible inferno. The moment the hatch opens, a wave of scorching energy rushes in, a force so intense it could melt steel in seconds. Your suit systems scream warnings. Temperatures here exceed 1700 degrees Fahrenheit, hotter than the surface of Mercury, enough to liquefy metals and shatter anything not built for pure, unrelenting heat. Beneath your feet, the ground is not like anything found on Earth. It is blackened, glassy, and cracked from extreme thermal stress. In the distance, towering crystalline formations glimmer ominously under the hellish glare of 55 Cancri A, their jagged surfaces reflecting an eerie glow. But if the diamond planet theory is correct, then those formations, those vast mountain ranges stretching into the boiling sky, could be pure, uncut diamond, worth more than all the wealth of human history combined. But this world does not welcome visitors. The air, if you could call it that, is a toxic blend of carbon monoxide and vaporized rock, thick with elements ripped from the surface by the planet's relentless star. And then there's the fire. Rivers of lava carve through the terrain, twisting like molten veins of a living planet, constantly reshaped by the intense gravitational pull of its sun. Every few moments, the ground trembles, not from earthquakes as we know them, but from the planet's own thermal expansion, rock cracking under the stress of constant brutal heat. But what if you could survive here? What if you could walk across this world without being instantly vaporized? What would you see? First, the sky. Unlike Earth's soft blues and golden sunsets, the sky of 55 Cancri E would be an infernal spectacle of deep reds, blazing oranges, and blinding white light. Because the planet is so close to its star, its sun would dominate the sky, filling the heavens with an eternal, blinding fire. There would be no blue, no atmospheric scattering to soften the glare. The entire world would exist under the relentless weight of its sun's fury. And then there would be the night side. If you could somehow make the impossible journey from the scorched day side to the dark hemisphere, you would enter a realm of frozen silence. Temperatures would drop to unimaginable lows, colder than the void of space itself. Here the air would be still, untouched by the chaos of the burning side, but it would not be peaceful. Without sunlight, the ground might be coated in an eerie frost-like layer of crystallized gases, frozen in place, like a world trapped between fire and ice. And there, in the blackness, you might see something else. Something incredible. The glow of the planet's own surface. Scientists believe that 55 Cancri E may not just reflect light, it may emit it. Data from the Spitzer Space Telescope suggests that the intense heat on the day side causes some of the planet's rock to vaporize, forming an atmosphere of molten minerals. But as the planet rotates slightly, these vaporized minerals cool and rain back down as molten rock. Imagine a place where the rain itself is lava, where droplets of liquid stone fall from the sky and harden upon impact. A world where the land itself glows like embers in a dying fire. But how did this world come to be? To understand the origins of 55 Cancri A, we need to look at how planets form. Our own Earth was born in a chaotic, violent past, a world of molten oceans and endless collisions. But over time, as it cooled, the elements within it separated. Heavy metals like iron and nickel sank to the core, while lighter elements formed the surface. Carbon, one of the most abundant elements in the universe, was present, but not in large enough quantities to shape the planet. 55 Cancri A, however, may have formed under entirely different conditions. Some scientists believe that this planet was once much farther from its star, forming in a region rich in carbon. If so, its internal chemistry would have been wildly different from Earth's. Instead of iron-rich rocks and silicate crusts, this world could have been built with carbon compounds under extreme pressure, enough pressure to compress much of its interior into diamond. But then something changed, something catastrophic. Over millions of years, gravitational forces may have pulled 55 Cancri E inward, dragging it closer and closer to its star. This journey would have reshaped the planet in unimaginable ways. As it moved inward, its atmosphere could have been stripped away, its surface transformed by extreme heat and radiation. If it was ever an Earth-like world, if it ever had oceans, continents, or even the potential for life, those possibilities were erased by fire. What remains today is a broken, scorched remnant of what once was, or what could have been. But not all scientists agree on the diamond planet theory. Some argue that 55 Cancri E might not be as carbon-rich as once thought. Instead, they propose that the planet's surface is covered in lava oceans, vast churning seas of molten rock, constantly shifting under the extreme heat. If this is true, then the glittering diamond landscape might just be a dream, a mirage formed by our desire to see something truly extraordinary. So which is it? A diamond world worth more than the human mind can comprehend, or a fiery, uninhabitable wasteland, forever lost to the crushing pull of its sun? The truth is, we don't know. Not yet. But one day we might. If humanity ever builds the technology to travel beyond our solar system, 55 Cancri E will be one of the first places we seek to explore. Not because we expect to colonize it, but because it holds secrets about the universe, about planetary formation, and perhaps even about the fate of worlds like our own. But that raises an even bigger question. If planets like this exist, what other strange, unimaginable worlds are waiting to be discovered? And more importantly, could one of them hold something even greater than diamonds? The idea of a diamond planet is breathtaking. But what if 55 Cancri E is just the beginning? What if our galaxy is filled with worlds even more bizarre, more valuable, more utterly alien than anything we've ever imagined? Let's take a step back and look at the bigger picture. The universe is old, nearly 14 billion years old. That's more than enough time for countless planets to have formed under conditions radically different from our own. And yet, we've only just begun to scratch the surface of what's out there. We've found planets with skies of burning glass, planets that rain liquid metal, and even rogue planets drifting in eternal darkness without a star. But when it comes to wealth, true, unfathomable wealth, 55 Cancri E has captured our imaginations like no other. If this world really is made of diamond, then its value would be incomprehensible. Here on Earth, diamonds are formed deep underground, where immense pressure forces carbon atoms into their crystalline structure. It takes billions of years for nature to create what we consider to be some of the rarest and most precious gemstones on our planet. But on 55 Cancri, this process could have happened on a planetary scale, meaning that its interior might be one massive, unbroken expanse of diamond stretching for thousands of miles. But this raises a fascinating question. What if we could reach it? For centuries, humanity has dreamed of space travel, of venturing beyond our solar system to claim the riches of the cosmos. In science fiction, we imagine fleets of starships mining asteroids, extracting gold, platinum, and rare elements from the vacuum of space. But the reality is, we're nowhere near ready. Even our most ambitious spacecraft, like Voyager 1 and 2, have barely begun to leave the boundaries of our solar system. The distance to 55 Cancri E, 41 light-years, is an insurmountable journey with our current technology. If we sent a spacecraft today, using our fastest propulsion systems, it would take hundreds of thousands of years to arrive. But what if that changed? What if we discovered a new form of propulsion, something that could cut travel times from millennia to mere decades? Suddenly, planets like 55 Cancri would go from being untouchable fantasies to actual destinations. And if we could reach them, what would we do? Would we mine their riches, stripping them bare in pursuit of unimaginable wealth? Would corporations stake claims to entire planets, turning them into factories for interstellar commerce? Or would we simply stand in awe, realizing that some places are meant to remain untouched? But there's something else to consider, something far more intriguing than mere wealth. If 55 Cancri is a carbon-rich planet, then it might contain something even more valuable than diamonds. Something that, if discovered, could change the course of human history forever. It might contain life. Now, at first glance, this seems impossible. How could life exist on a world where temperatures melt iron, where the atmosphere is toxic, where the ground itself is either molten lava or solid? Diamond? Surely nothing could survive here, right? Well, not necessarily. Here on Earth, we've found life in some of the most extreme environments imaginable. In the deepest trenches of the ocean, where pressures would crush a human in an instant, we've discovered creatures thriving in total darkness. In volcanic vents, where temperatures exceed those found on the surface of Venus, life persists. Even in Antarctica, where subglacial lakes remain frozen for millions of years, microscopic organisms continue to exist. Life, as it turns out, is stubborn. It refuses to be bound by what we think is possible. So what if, buried deep beneath the surface of 55 Cancri, in some protected region where conditions are just right, something is alive? It wouldn't be life as we know it. It wouldn't be plants or animals or anything remotely familiar. It might be something entirely different, something that evolved under crushing gravity, in an environment of superheated rock and carbon chemistry beyond our understanding. If such life exists, it could provide answers to one of the greatest questions in human history. Are we alone in the universe? But here's the problem. We may never know. Despite our best efforts, 55 Cancri remains a mystery. We can study it from afar, analyze its heat emissions, its chemical makeup, its gravitational interactions, but we can't see it directly. Our telescopes, as powerful as they are, only give us glimpses of the truth. We are like ancient explorers, standing on the shores of an undiscovered continent, staring out at the horizon, knowing that something is out there, something incredible, yet unable to reach it. And that's what makes this planet so captivating. It is a symbol of the unknown, a reminder that no matter how much we learn, the universe will always hold secrets beyond our grasp. It forces us to ask questions about wealth, about exploration, about the very nature of existence itself. If planets like 55 Cancri exist, then what else is out there? Are there worlds even stranger, even more extreme? Could there be planets made entirely of metal or ice or something we haven't even conceived of yet? And more importantly, what happens when we finally find them? Because make no mistake, our search is just beginning. Humanity is still in its infancy when it comes to space exploration. We are barely able to leave our own planet, let alone reach distant stars. But if history has taught us anything, it's that curiosity is an unstoppable force. One day, we will go. One day, we will stand on alien worlds and gaze at alien skies. And when that day comes, what will we find? One day, perhaps centuries from now, the first human spacecraft will arrive at 55 Cancri. A probe, a fleet, maybe even a manned mission. Something will cross the cosmic ocean and finally touch this forbidden world. And when it does, we will have answers. We will know definitively whether this is a planet of diamond or something else entirely. But with those answers will come new questions, and an even deeper realization of how little we truly know. Because by then we won't just be searching for wealth, we'll be searching for meaning. Imagine the moment a robotic lander descends onto 55 Cancri, its thrusters struggling against the planet's gravity. As it touches down, its instruments will begin scanning the surface, mapping its chemical composition, searching for signs of what we have long suspected. The first image it sends back to Earth could be history in the making, a snapshot of a world unlike anything seen before. Will we see endless plains of shimmering crystal, reflecting the light of its star in a way no human eye has ever witnessed? Will jagged peaks of pure carbon rise like frozen waves, sculpted by millennia of fire? Or will we be confronted with something far more chaotic, an endless shifting landscape of lava, bubbling and churning like the infernal heart of a living planet? And then comes the ultimate dilemma. What do we do with this knowledge? The moment we confirm that 55 Cancri E is a diamond planet, something unprecedented will happen. The greatest fortune in the history of civilization will have been discovered. A single celestial body worth more than the combined wealth of Earth, perhaps 1,000, even 1,000,000 times over. And the scramble to reach it will begin. Corporations, nations, private ventures, everyone with the means to launch into deep space will set their sights on this new frontier, not for science, not for exploration, but for power. Because wealth at this scale isn't just valuable, it's civilization-altering. A single mission capable of extracting even a fraction of the planet's riches could destabilize entire economies. The price of diamonds, once treasured for their rarity, could plummet to nothing. The very foundation of global wealth could be rewritten in an instant. But here's the irony. The cost of reaching 55 Cancri E might outweigh the value of what that holds. Mining an entire planet is no simple feat. The technology required to strip mine a celestial body, especially one with extreme temperatures and crushing gravity, would be beyond anything we currently possess. And even if we did extract diamonds on a massive scale, the moment they flood the market, their worth would vanish. What was once priceless would become common. The greatest treasure in the galaxy might be nothing more than an illusion, a reminder. That value is not determined by rarity alone, but by the stories we tell ourselves. And then there's another, far greater question. Should we even try? Humanity has a long history of taking, of conquering, of exploiting resources without thinking of the consequences. We have leveled mountains, drained oceans, and pushed our own planet to the brink. And now we look to the stars, not just for wonder, but for profit. If we ever reach 55 Cancri E, will we treat it as a scientific marvel, a monument to the mysteries of the universe? Or will we strip it bare, reducing it to nothing more than another asset in our never-ending pursuit of wealth? But there is another possibility. Perhaps 55 Cancri E isn't a prize to be claimed, but a lesson to be learned, a reminder that the universe is vast, indifferent, and filled with things beyond our understanding. A reminder that some worlds are not meant to be owned, but simply to be known. That not everything of value can be measured in currency or possession, because in the end the true wealth of 55 Cancri E isn't its diamonds. It's the mystery itself. It's the fact that such a place can even exist. That we, tiny creatures clinging to a small blue world, can even begin to fathom it. That we are capable of looking up at the night sky, pointing to a distant star, and asking, what's out there? That is what truly matters. And so, the search continues. 55 Cancri E is only one world in a galaxy of billions, but if a planet of fire and diamonds can exist, then what else is waiting for us? What other impossible, breathtaking wonders are hidden among the stars, and more importantly, are we ready to find them? If this journey has sparked your curiosity, if you want to keep exploring the unknown, then help us grow this community. Like, share, and comment below. What do you think we'll find on 55 Cancri E? Is it a diamond world, or something even stranger? Your thoughts could lead to the next great cosmic discussion. The universe is waiting, and we're just getting started.